not just getting a chance to share some of my research from MIT, but also to hearing back from you. I discovered early on in my career that the best way to really understand the effects of information technology and the reorganization of work was not to simply go to my office and close the doors and windows and try to think deep thoughts about what was happening, but to go out and visit the companies and visit the industries and the workers who were actually involved in changing how things were going. So I'm very privileged to have a chance to come here to Finland, one of the great high-tech capitals of the planet, and learn from people like Yuri here in the second row, and Shalan sitting there as well, and many of the rest of you. And I'm hoping that after I finish my remarks, we'll have a robust question and answer where you will ask me some questions about the work we're doing, and I will learn from you some of the issues and challenges that you are facing today, so I can bring those back and incorporate them into my ongoing research. And one more person I'd like to thank. When I was writing that dissertation on information technology and the research work, I have to embarrassingly say about 27 years ago, I came to MIT because I thought that was the best place where technologists would come together and some of the best economists. But shortly after I got there, I realized that actually the very best economist understanding information economics was not at MIT. He was at Yale, and as a young graduate student, I mustered up the courage to send him an email. We did have email back in those days. And he was very kind to reply to me and give me a lot of help on my dissertation. And so I want to not only thank Brynjolfsson for helping me 27 years ago, but also for suggesting that I come here. So I'm in debt to you once again, Ben. Thank you very much for inviting me. So what I'd like to talk about today is the second machine age, and particularly the second wave, which I've really only discovered since I wrote that book with Andy a couple of years ago. I've really only come to an appreciation of it, and I want to share with you some of the ways that this second wave is beginning to transform the economy in ways that I couldn't have even imagined a few years ago. And we'll talk about not just the technologies of that, but also some of the economic implications. But let me step back and first ask a simple question, which is, how many people here in this room would like to have the power to truly transform the world? Who would like to be able to change the world? Anybody? Okay. Everybody would like to change the world. So what does it take to change the world? Well, you could say that it takes a small group of highly committed people. Some people have said that. You could say it takes an insanely great idea. But I'm going to give you kind of an MIT perspective, a kind of an engineering perspective. And I'm going to argue that it takes two things to change the world. You need a power system and a control system, a little bit of an engineering perspective. You need the power system because the world is mostly made of atoms, and they're held in place by powerful forces, like you learn in physics class, like electromagnetism and gravity. And you literally need power, physical power, to change the world, to move things around, to rearrange things. But you don't just need power, you also need a control system so that you can understand how to arrange them, how to organize them. Now, for most of human history, both the power system and the control system was humans. We relied on people to do those sorts of things. But then about a little over 200 years ago, we had the Industrial Revolution, and we started having machines that provided the power system, starting with the steam engine in the 1780s. James Watt made a much better steam engine, and that ignited the Industrial Revolution. But then later, the internal combustion engine and electricity, and these provided more and more power, and we replaced human and animal muscles with machines. And as a result, we had a big increase in living standards. We were about 30 to 100 times wealthier than our ancestors were, depending on how you measure things. The other thing we could say about these technologies is that they were mostly a complement to humans. That is to say that the better the machines became, the more valuable humans became. And we know this because wages were rising. So the cost, the value of having 1 hour of human labor went up and up and up all during this period. I would argue that we are now in the early stages of what Andy and I call the second machine age. And now we're beginning to use machines not just for the power system, but also for the control system. Not just for muscles, but for mental tasks as well. And And there are some powerful general purpose technologies that do this: computers, software, big data, machine intelligence that are advancing in this area. It's still an open question to what extent this is going to be a complement or a substitute. In some ways it makes humans more valuable, but we're also seeing, and I'll show you the data later, that in some ways it's substituting humans and making them less valuable, reducing the value of an hour of labor and putting pressure on wages, and in some cases, for many people, their incomes. But ultimately, I think this is going to have a profound effect on the economy, as big as the Industrial Revolution. And that's really quite big, because if you look at human history, you can look at it in many ways. There have been wars and empires and religions and discoveries, but in terms of economic progress, in terms of basic fundamental metrics, there's really only been one big transition point, and that was back in the late 1700s, exactly when I said the Industrial Revolution was launched. And it may be a coincidence, but my belief is that that first machine age, when we started augmenting our muscles, replacing them with machines, was what gave rise to this transition in human history. So let me give you a little bit of background on the second machine age now. And most of it, up until now, up until today, has been focused on what I would call the first wave, which is taking all the knowledge that we have and teaching it to machines. So, for instance, in tax preparation software or arithmetic or other repetitive tasks, what we do is we codify knowledge. Literally, there are millions of people whose job is to do coding. That's what they call it in Silicon Valley and elsewhere. And coding, in essence, means taking something that we have thought through and codifying it in such a way that the machine can follow those instructions and do exactly what we tell it. And if any of you have ever tried to code, to write computer programs, you know that you have to be very, very precise. If you don't say it exactly right, the machine won't work. The machine is very, very literal, so you have to really understand what it is, the problem you're solving, and exactly step by step how you will solve it, so that you can teach the machine. You can show the machine how to do it. Now, it's been quite successful. It's been dominating the software industry and transforming the economy tremendously, whether it's in payroll processing or assembly lines or tax preparation. It tends to have very high fixed costs and low marginal costs, so you get these industries often with winner-take-all markets. By and large, I think it's been success. It's one of the reasons that we've had some growth in living standards in the early stages of the second machine age, this first wave of the second machine age. For instance, there's been a tremendous increase in wealth, not just in the measured GDP, but today at lunch I was talking to a number of colleagues, and we were discussing some of the unmeasured benefits. For instance, this newspaper ad here was from 1993, and if you look closely, there's a lot of objects in there. There's a computer, a video recorder, a camera, a tape player, an answering machine. Do you guys remember what an answering machine is? Music, and many other devices, calculator, computer, of course. What's interesting is essentially all of those applications are now bundled into your smartphone for free. So we get many benefits, hundreds of dollars worth of benefits. We now don't have to pay any additional cost once we have a smartphone. And there are new applications that we couldn't have bought at any price. In 1993, only the military had access to GPS-type technologies, and even a few years later, it cost hundreds of dollars. Now I have 4 different GPS applications for free on my phone, and there are many other things that are available for free. It's worth noting that these raise our living standards, but they, by and large, don't show up in our GDP statistics. They don't show up in our productivity statistics. So our well-being is improving far more than our measured statistics reveal. And this is something that we're going to have to grapple with as software eats more of the world, as more and more of the goods and services that we consume, not just in smartphones, but in our smart automobiles or our smart banking or many other areas. As they become based on these technologies, the benefits will not be captured well in our existing economic statistics. But there are some limits. There are only so far you can push this technology of codifying knowledge and putting it into machines. And it's well described by something that's called Polanyi's paradox. My colleague David Otter, an economist, has written extensively about this and other people as well. Polanyi was actually a sociologist, and he made this very important insight that we all know much more than we can tell. We may know how to ride a bicycle, but it'd be very difficult to read a book and give a book to a child. Say, here, read this book and then you will learn how to ride a bike. It doesn't work that way. Or the example that Kalani gave was recognizing a person's face. You can instantly recognize your mother's face or someone else's face out of a million possible faces, but it'd be very hard to describe it. Oh, the eyes are about this far apart. It would be almost impossible to describe that in any explicit description. And because of this technique of codifying knowledge, of writing it down step by step, doesn't work for a lot of our important knowledge. Some of the most important things we do are almost impossible to codify. And some people, like David Otter, see this as a fundamental limit to how far we can go with our machines and how much machines can ultimately do, and that there will always be things that only humans can do. But that's changing. We're now in the second wave of the second machine age. And in fact, one of the things that machines are learning to do quite well is to recognize faces. In fact, when I wrote the book, that work in the second machine, the book, The Second Machine Age, humans were much better than machines at recognizing faces. Today, 2 years later, machines can often recognize faces better than humans. It used to be that reading a street sign, you go down to driving, a human could do that better than a machine. Today, a machine can recognize and read signs as well or better than machines. It used to be that a human could read an X-ray and diagnose cancer better than machines. Today, machines can do that better. And it's because we are beginning to move beyond just codifying knowledge into a new wave, which is machine learning, and having the machines learn on their own how to do some of these tasks. So vision has improved quite dramatically. There's a database called ImageNet, and here's some of the pictures on the left that are very small, but there are tens of thousands of images in it. And one of the projects that artificial intelligence researchers do is they show these images to machines and they say, can you tell us what this is? Is this a house or a car, a dog or a cat, a bird? Is this a computer or a robot? Is this a building? And it used to be the machines were not very good at it, but as you can see on the right panel there, they've improved quite a bit. Since 2010, they went from having about a 30% error rate to now it's less than 5%. And just as a benchmark, humans are about 5 to 6% error rate. Even humans are not perfect. Sometimes you don't know what kind of bird is that. Is that a blackbird or a sparrow? And so humans make mistakes as well in these image nets as well. And we're rapidly getting to the point where the machines are actually somewhat better than the humans. And it's because of, as I note here, we've set a new set of techniques called deep learning. And I'm going to explain those a little bit how they work. But they have many applications, from the self-driving cars. Companies like Mobileye are using vision systems so that machines can see where there's a bicycle, where there's a car, where there's a tree, where's the edge of the road. My friend Jeremy Howard at Analytic is using it to help diagnose cancer. And it's part of a broader category of artificial intelligence. Within that subcategory is machine learning. And then within that category is this subcategory of deep learning. Let me just briefly explain this to you. It's not super technical, but if you're going to have an MIT professor come and speak, I think you want to see at least a few equations and some jobs, so you get your money's worth. So on the left here is a neuron and neural nets, and it basically takes the weighted average of several inputs. For instance, x1, x2, and x3 could be pixels on a screen. So that instead of having 3, we might have 1 million pixels. But I didn't want to make 1 million x's, so we just have 3 of them here. So some of them are black, some of them are white, some of them are red or green. They get put into a weighted function with a weight of 1, 2, or 3, that can be a high weight or a low weight. And then there's a function b that only sends an output if the weight is above some threshold. So if all the pixels are a large number, then it sends out a signal. If the pixels are a small number, like they're all black, then it sends out a small 0, a no number. Very, very simple little artificial neuron. It's inspired loosely by the way our own neurons work, for those of you who know something about neurobiology. It's not exactly like this, but it's a little bit of an inspiration. The dendrites feed in, the axon sends out information. And then you can see over here on the right, you can put many of these together, hundreds of thousands or millions of them together with different connections, and depending on how they're put together, they start being able to do simple classification tasks. So the first layer there may be all the pixels of the screen. The next layer starts identifying some very simple characteristics. For instance, this is a line, this is an edge, this is a circle, and the next layer starts identifying more sophisticated things. This is a circle, and eventually things like this is an eye, this is a nose, this is a face, this is Sylvester Stallone's face, this is Madonna's face, and it starts becoming more and more sophisticated as it works through the layers. The state-of-the-art systems today will have typically between 9 and 12 layers. Some people have built systems with far more layers, and they feed in large amounts of data, and this essentially is how the deep learning algorithms work. Of course, it's much more complicated. Once you get into the details, there are thousands of people working on the mathematics of this, but that is the essence of this new wave of deep learning. The reason it's called deep learning is because they have many, many layers of deep neural network, not just one layer. The early ones only had 1 or 2 layers, but now you have, as I say, 10 or more layers. And the key to making them work is feeding very large amounts of data. So we're in this digital age, we're very fortunate where enormous amounts of data are available. If you look at Google or Facebook or Amazon, they have billions of observations of data that they can feed into these systems, from people speaking into the Android phone or a Siri, or from images. And here's an example of feeding in many, many images in Etla into a system that does medical diagnosis. You show a lot of pictures of, here are people who don't have cancer, and on the right, oh, here are people who did have cancer, and they go into the system, and the system starts figuring out, how can we make a distinction? What's the difference between the cancer and the not-cancer? And this system has identified a dozen or so key characteristics that are common in cancer, the same ones that are taught in the pathology labs at Stanford Medical School, at Harvard Medical School, and elsewhere. What's interesting is they keep the system running, and it identified 3 or 4 new characteristics that were never taught in any of the textbooks. But it discovered on its own these other ways of distinguishing cancer from not cancer. And if you have enough data, you can make more and more of these inferences. So the state of the art right now, where these systems are strongest, are places where you put in lots of what's called tagged data, classified with examples of what you're looking for, and also importantly, what you're not looking for. This is a dog, this is a cat, this is a stop sign, this is a yield sign, this is somebody saying the word yes, this is someone saying the word no. If you put enough data in, it will distinguish between the two. And it'll learn on its own. You don't have to say the rules. In fact, one of the unfortunate things about it is that it's often difficult to understand this tangle of neurons, exactly how it's making the decision. You get the inputs and you get the output, but understanding the layers in between can be very, very difficult. And so you just have to, in some ways, trust that the system is doing the right thing. And that can be an area of concern. So they have been able to use these systems not only in static images, but also to learn to do things. And there's a subcategory called reinforcement learning that has been very powerful for teaching systems to learn on their own how to solve problems. Simple problems, but problems nonetheless. So for instance, people like Dennis Hassabis at DeepMind has, with his team, worked on a deep Q network, which is a special kind of reinforcement network. And I'm going to see if I can get this to show you. One of the things they've done is they have fed in pixels from an Atari video game. I don't know if you've ever played, for instance, Breakout. And when they first started feeding the data, you can see it wasn't so good. It's missing the ball a lot. Not quite perfect, but it's beginning to learn how to play a little bit. And then after 300 games, it starts getting a little bit better. It's getting feedback, and the only information they give it is the pixels and the score. And they say, you can move this left or right and just try to make the score as high as possible. And it makes some errors, but eventually it says, oh, if I have it hit the pixel at the right time, it will make a higher and higher score. And it even discovered something that the programmers didn't know. It learned this new technique here. You can see it's figured out how to send the ball around back and get very, very high scores. This is something that the programmers, they tell me they didn't know that it could do that. So the system on its own figured that out just after 500 games of learning. Now, of course, that's a simple video game. They do it also with Space Invaders, Pac-Man, and other simple video games like that, where they feed the data in. but it's reinforcement. It's the same thing that happens in our own brain. Dennis actually happens to be a neuroscientist who studied at MIT for his postdoc. And we do the same thing. We try to solve a problem, and then if we do it correctly, we get positive reward, positive feedback, we do more of it. If things aren't working, we do less of it. And the machine is learning to have that kind of feedback. This is a video game. It's just pixels. Could we bring this to the real world? And the answer is yes. They are teaching machines to do things in the real world. Here's a machine that's learning how to catch things. You throw things to it, and it catches them in midair. There's a video of it on the web if you want. But at first it misses, but then if it gets close and catches it, it starts doing more of what it needs to do to track the object and catch it. You can see how you could develop a robot that would do other tasks, that would open a door or walk upstairs. Well, what was the example I gave at the beginning of Polanyi's paradox? Riding a bicycle. Could we have him do that? So here's one that's learning how to ride a bicycle. It's not something we wrote the rules down, not something you can do that, but it's something that the machine is learning from a feedback loop on its own. Now, the second wave has some amazing applications that are going to change the world even more, I think, than the first wave did, and it's important to think about them. There are three big categories that used to be uniquely human, that only people could do, that now we're changing. And if I was giving this talk 10 years ago, this would have been the list of things that humans can do, machines cannot do. Now it's becoming the list of things that machines are learning how to do. Interacting with the physical world, understanding and speaking language, and solving problems in different ways. Let me briefly give you some examples. 3 days ago, these cars started driving around in Singapore. If you go to Singapore, has anyone been to Singapore recently? You can go and take a taxi with no human driver. This is a project, there's an MIT team, Daniela Roos, the head of the MIT CSAIL, Computer Science and AI Lab, has been flying back and forth to Singapore to help them develop this project. She's not allowed to do it in Massachusetts because our laws prevent them from having self-driving cars in the streets of Boston. It's dangerous enough with the human drivers, I guess. But in Singapore, they're a little more flexible, so we have these self-driving cars. And in Pittsburgh, Pennsylvania in the United States, Uber next month is going to have self-driving cars as well, where you can use your Uber app and call a self-driving car. Now, I should say they have a little safety system in there. They will still have a human sitting in the front seat behind the steering wheel, but the car will drive itself, and then I guess the human is there in case something goes wrong. The human is supposed to take over. But you can see this is evolving quite rapidly, and it's mainly because these deep learning systems have gotten so good at vision and other senses that used to be uniquely human. If they don't have to have wheels, MIT is starting classes next week, and if you thought the final exams were scary, you should see what they have out on the front lawn. This cheetah, I went and I saw it running around at MIT. They could run faster than a human, faster than Usain Bolt. If you go a 100-yard dash, this can go about 29 miles per hour. If you throw a chair in front of it or an object, it will jump over it. So it's fairly nimble. And then there are many of these robots in practical applications. I have a Baxter like this in my office. I have it sitting next to my desk, but most of them are in factories in places like China, and they're doing simple tasks, taking objects off of a conveyor belt and putting them in a box. A very boring task, but it requires a certain amount of vision and senses. Millions of humans do this job, as you know, in factories, taking things and putting them into boxes. Baxter can do the same thing. Baxter costs a little over $20,000, about $20,000, $24,000. Can work 7 days a week, 24 hours a day. It doesn't work quite as fast as a human. I've seen it. It's a little bit slower, but it's fairly nimble. According to Rod Brooks, who used to be the head of the Computer Science and AI Lab, and who founded Rethink Robotics, he says that Baxter works for about the equivalent of $4 an hour. So that's sort of the benchmark right now, just thinking tasks like that, $4 an hour. And of course, with the advances in Moore's Law technology, you can expect that to be $3 an hour and $2 an hour and $1 an hour as the technology continues to improve. In fact, Baxter's already a little bit out of date. Rethink Robotics has introduced a next generation robot called Sawyer, which is over twice as fast as Baxter and much more nimble. And we see the shipments of robots going up quite a bit. The one on the left, those are humans actually, and then on the right is the chart with the robot growth over time. Some factories are beginning to replace all of the humans with robots in some categories. We also see big advances in voice recognition. You know, today, if you see somebody walking down the street and you see them talking to their phone, you don't really know, are they talking through the phone to another human? Or are they talking to the machine and expecting the machine to talk back to them? You know, 10 years ago, that would have been insane if you were talking to a machine and expecting the machine to talk back. But now, that's very routine. I don't think Siri or Google Now is all that good. It's just the beginning. But you are beginning to have a thing where you say, hey, what's the weather? What's new, Siri? I have an Echo, Amazon Echo. And when I come home and I walk in the door, I say, what's new, Echo? Or what's new, Alexa, actually. And then it speaks back to me. So it's getting a few simple steps, but you can see that we're in the middle of this about 10-year period where we went from machines not understanding us to machines routinely understanding us. Think about that. That's a huge milestone in human history when we can talk to our machines in ordinary language and have them respond and answer our questions for us. And not just in our own language, we can have them translate. If you use Skype, you can now speak into it in English and have it come out in German or French, which I haven't checked Finnish yet, but I'm sure that they'll have that soon as well. And it can even write stories on its own. So companies like Automated Insights or Narrative Science are having the machines write stories from scratch. Next time you read the newspaper, read carefully, not just the news, but look down the corner here. This story was generated by Automated Insights. This story was written by Automated Insights. They take the data from the stock market and elsewhere, and they generate a simple story. I don't think they're good enough to write a PhD dissertation yet, or a novel, or a great piece of literature, but for simple stories about sports or finance, they're doing this. There are hundreds of thousands of news stories today that are being written by these machines. And maybe some of the most fun is what they're doing in some of the games and problem solving. You may know the game Jeopardy, where they ask complicated questions about literature or science or sports or current events or entertainment or geography. It could be about anything. And the humans have to answer it. And a couple of years ago, IBM's Watson played against it. David Ferrucci came to my class at MIT, and he showed me how they were progressing. And here's a little chart of how he did the analysis. On the vertical axis is how many questions you get correct, and on the horizontal axis is how aggressive you are, whether you try to answer all of the questions or only just some of the questions. And the little blue dots, those are the things that look like mosquitoes up there, those are the humans. Those are the human champions, the very best humans playing Jeopardy. And you can see most of them are very good. They get 80, 90, even 100% of the questions correct in any given game. And this was Watson. When they first introduced Watson, it wasn't really very good. You could get maybe 20 or 30% of the questions correct. It's a line instead of a dot because there's a little dial. You can make it very aggressive, try to answer everything, and it only gets maybe 10% correct, or it can be more conservative and only answer the ones that it was very confident about, but even then less than 50%. So Watson wasn't all that useful. But Watson had one characteristic that the humans didn't have, and that was the ability to learn very, very rapidly, ingest a lot of data. They started feeding Watson data from Wikipedia, all the information. Watson, by the way, is not connected to the internet, but it can store the data internally. So Wikipedia and other information, at one point they added information from something called the Urban Dictionary, which has a lot of slang words. It turned out that wasn't such a good idea because some of the questions that Watson answered, he used inappropriate language, shall we say, in its answers. So they wiped that part of its memory out. But you can see that within a few months, Watson was performing as well or better as the human champions. By 2010, it was better than most of the human champions. And a few months after that, they played on national television, and of course, Watson defeated the human champions. And this is a very broad set of questions. It's still just a game. They won $75,000, but that wasn't the real purpose of Watson. It was to demonstrate this technology could be used in many different applications. From call centers. What is a call center after all? It's a question answering. When you call in to the call center, you expect a human to answer your questions for you. Watson is doing that in a South African call center right now. You can use it in legal categories. You can use it in banking and financial advice. You can use it in medical diagnosis. There are technologies now used in big law firms where the system will sift through documents and replace the human lawyers at identifying which are the relevant parts of the documents you want to use in a legal case. And there are even machines that are being used for hiring and for making decisions about which humans get hired and which humans don't get hired. So I'm advising a company called NAP that does exactly that, using some of these machine learning techniques to say this person would be good for a call center, this person would be good for a programming job, and this person, well, maybe we shouldn't hire them at all. And the machine is making those decisions. Well, I could give many more examples specifically, but I want to talk now about some of the broader trends about what this means for the economy. And I think there's good news. It's making the economy more productive and more efficient and growing the amount of wealth far more than it showed up in the official statistics. That's good news. But it's also being very uneven. There are some people who are benefiting a lot. There are millionaires and billionaires being created. We have more millionaires and billionaires than ever before in human history. But we also have median income stagnating. Many people are falling behind. And it's from this fundamental insight that we talk about, first the race against the machine and then the second machine age, which is that there's simply no economic law that says that everyone is going to benefit evenly from these technologies. It's possible for some people to be left behind. In fact, according to economic theory, it's possible for a majority of people, more than half the people, could be left behind by some of these new technologies. That's not what happened for most of the past 200 years. With the first machine age, it was a rising tide that lifted all boats. But recently, things are changing. Let me show you some data. Here's what I've started calling the Great Decoupling. This is from an article we wrote in the Harvard Business Review. The top line, the gray line, is what's happening with labor productivity. But the bottom line, the blue line, is what's happening with median family income. And these are from the United States data. As you can see, for much of the 20th century, these rose together. It was like a rising tide that lifted all boats. The social contract was, as the economy became more efficient and productive and more wealth was being created, we would all benefit from it. The top, the middle, the bottom. But since then, things haven't been as even. They've become decoupled. Productivity has continued to grow. GDP has continued to grow. You can see the Great Recession there at the end. But employment has come close to stagnating. It's begun, this chart is a little out of date, it's begun picking up a little bit, but it's still far behind the other ones. And median family income today in the United States is lower than it was in 1998. So it bounced around a little bit. It's beginning to rise again, but it's still behind where it was. Median, I want to emphasize, median is the income at the 50th percentile. So it's not the same as average income. Average income is growing like GDP per capita, but median income is lower. How is it possible that average grows faster than median? Well, it's because things are becoming more uneven. A lot of the benefits are going to the top 1%, or the top 1/10 of 1%, or the top 100th of 1%. So although the average is going up, the median isn't changing at all. And in Finland, we see some of this that's going on. There hasn't been as much income inequality in Finland, but there have been issues around job creation and employment. The share of the population that's working now is less than it was 10 or 15 years ago. So how is this possible? And as I mentioned, the way it's possible is that technology can make the pie bigger, but it also can create winners and losers. There's no economic law that says that everybody wins evenly. What are the three ways we can have winners and losers? Well, there's something called skill bias technical change that's been widely studied. I've written some papers on it and others. There's this balance between capital and labor. Thomas Piketty and others have talked about that. And then there's something, doesn't have a good name for it, but superstars versus everyone else, this winner-take-all kind of economy. Let me briefly give some examples, and then very soon I want to open the floor up and take questions and discussion from all of you. So high and mid-skilled workers, many of them have been automated. Many of the most routine, repetitive jobs are exactly the ones that are easiest to automate. So more and more, when I go into a restaurant now, instead of talking to a human, I talk to an iPad. I was in LaGuardia Airport recently, and a year ago, I went to my favorite cafe. It there was a human waiter. Today, I go to that same cafe, and there's a little like iPad where I do my ordering, and I pay my bill through that. It's cheaper, more efficient, and faster to do it that way. Those kinds of very simple jobs are often the easiest ones to automate, and we're seeing that happen more and more widely, not just in restaurants, but in many other categories. And the data show that there's been a spreading out in terms of the income. So I think a large percentage of you in here have PhDs. I was reading about that. I won't ask how many of you have PhDs, but you're lucky because you're up there at the top of the chart there. This is United States data, but it's similar worldwide, where people who have more education have done much better. Early on, everybody was rising, but since then, only the people with more education have continued to have their wages grow. If you are a high school dropout or a high school graduate, you have lower wages now than you did 10, 20, 30 years ago, at least in the United States. This is for males. For females, the entire chart is skewed upward a little bit. Females in general are doing better than males, but there's still this spreading out based on education. And so that is what economists call skill-biased technical change. There's technical change is affecting some skill groups more than others. And this makes it look like it's all based on education, but that's not really the right way to think about it. It's a little more complicated than that. Here's some nice work by David Otter and Dorn. Doron Asimoglu has also contributed to this. And what you see is actually it's kind of a U-shaped distribution. On the right of the chart is the people at the highest skills wages, and the left is the lowest. And we have on the left chart is employment, and the right is wages. They both are U-shaped. And what's happened, especially recently, is that people in the middle of the distribution have been most affected. And those are exactly these routine information processing jobs. A clerk, a tax preparer, a travel reservation, a travel agent, those kinds of jobs. They pay okay, but they don't pay great. They have been hit the hardest by automation and also by globalization. At the very low end, actually, it hasn't been so automated. There are many tasks like being a nurse's aide or an orderly or a janitor that actually are very difficult to automate because they involve physical dexterity and movement. Walking up the stairs or just picking something up like this, that's actually quite difficult for a machine to do, but humans can do that. They don't get paid a lot for it, but we have these simple physical skills. And then, of course, at the other end, everyone knows that the high-end educated workers have done very well. So it's been a bit of a U-shaped distribution. The second type of biased technical change was capital versus labor. This is an old battle. I understand that Stalin and Lenin met for the first time here in Helsinki, so congratulations to you for that. But it's been a long discussion going back well before them to Karl Marx, and now Thomas Piketty and others have been talking about this trade-off between capital and labor. And the high-tech titans, people like Travis Kalanick, he's the founder and CEO of Uber, have made this connection that, wait a minute, if we take the worker out of the car, it's going to be a lot cheaper if we only just have to pay for the capital and no labor. And so he's working very hard, as I mentioned, in Pittsburgh and elsewhere, to replace all the labor with capital. Now, if he succeeds in doing that, three things are going to happen. One, consumers are going to be much better off. We're going to have access to cheaper cars, more reliable pickups. We're going to have cheap transportation wherever we want. So consumers will be better off. Two, Travis Kalanick is going to be a lot better off. Him and his investors are going to make a lot of money, and there'll be more billionaires coming out of that company. So that's two good things, but there's also something not so good, which is that a lot of the workers right now who've got jobs driving Ubers, they won't be needed anymore. They're going to have to find something else to do. So labor will lose out in that scenario, and I don't think it's so hypothetical. I told you it's already happening in Pittsburgh. This is what the data say. The red line is the share of GDP going to labor, going to workers. And it bounced around for many years based on the recession and the business cycle, but lately it's only been going basically in one direction, and that's downward. The share of GDP going to workers is lower now than it has been. And this is, again, not just the United States. This is a worldwide phenomenon. Japan, China, Germany. In fact, the last time I checked, which was about a year ago, for all the OECD countries except one, the labor share was falling. The only one where it wasn't falling was in Greece, which may not be the best model. So finally, there's a third type of biased technical change, and that's with the superstars. And so Michael Spence and Andy and I have written about this, labor, capital, and ideas in the power law economy. And we talk about superstars like Lady Gaga and Scott Cook, entertainer Scott Cook, who's the guy who wrote tax preparation software Intuit, and he is a billionaire. They've done very, very well because digital technologies allow you to take a little bit of talent and replicate it to lots more people. So if you have a good idea or a good singing voice, or maybe if you're just very lucky, you are able to take your talent or idea and make a copy of it. Once you digitize it, you can not only make one copy, you can make 10 copies, or you can make 100 million or 1 billion copies. And each of those copies can create some value for consumers, but also send back some value to the creator. And this tends to lead to power law distributions, where there's a small number, maybe one, of real winners, and a longer tail of people who aren't participating as much. After all, think of, I don't know, tax preparation software. You don't need 100,000 different tax preparation programs. You only need 1 or 2 or maybe 5 at most. So instead of having hundreds of thousands of human tax preparers, you can have just a single piece of software or a few that are replicated. And this is true in the power law economy. It's true for digital technologies. It's different from the old economy that was based on atoms. And again, the data support that this is something important going on here. Everybody has heard about the 1%. Well, it turns out that the 1% have their own 1%, the 0.01%. And just as the 1% have gotten a bigger share of income, the 0.01% have also gotten an even bigger share. It's been growing faster. This is a chart from Thomas Piketty's work, and you see that back in the early part of the 20th century, there was fairly high levels of inequality demonstrated by the share going to the top 1%. Then in the middle of the century, it leveled up, and now it's going up again to another all-time high and continues to grow quite a bit. So this is a sort of a fractal phenomenon that the higher you go up, the more concentrated the income has become. The 1% share of the 10% is greater than, and then the 0.01% share of the 1% is even greater, and the 0.001% share of the 0.1% continues to go up. So it's a more and more extreme distribution, just as a power law would predict. So I want you to think to yourself about, this is the data from the past 10 years. Well, how will things go forward? How will the second wave be different? Will it be more of the same? Or are we going to see some different things happen? Will we continue to have skill bias technical change, capital bias technical change, superstar bias technical change? Or are we in for some new things? And what kind of policies should we put in place to change things? I'd like to have a discussion with you about that. My own view is that these digital technologies are changing very rapidly, but our skills are not keeping pace, and a lot of people are being left behind. Our organizations are not adapting fast enough, and a lot of people are being left behind. I know that here in Finland, you've begun thinking very innovatively about other ways of organizing a society. People around the world are watching what's going to happen in Finland with your basic income experiment, which many people are advocating as one way of addressing this. I see just last week we had a seminar about this. I'm sorry I wasn't here in time to participate in that. But ultimately, I think it's time to start thinking about a new grand challenge. You know, that self-driving car that I showed you, that was actually invented in response to the DARPA Grand Challenge, the Defense Advanced Research Project Agency in the United States, put a challenge out to all the technologists and said, can you make a car that drives itself? And in 2004, when they made that challenge, nobody really thought that was going to work. And the first challenge, none of the cars could get more than a few hundred yards. In fact, believe it or not, one of the cars managed to drive up and flip itself over upside down. So they were just a disaster. But now, in the year 2016, we've achieved much of what DARPA was hoping to achieve with the grand challenge. But that was a challenge for technologists. I think now we don't need more challenges for technologists, or maybe not just technologists. We need some challenges for economists, some challenges for managers, and some challenges for policymakers and politicians. How can we respond to these technologies? How can we update our skills, organizations, and institutions? I think if we just keep doing the same thing, we could have growing inequality, we could have more concentration, and even if the pie gets bigger, a lot of people will be left behind. And we're already seeing some of the political implications when many people are left behind, when people aren't participating in the growth, they get upset. So I think we need to think about a challenge of addressing that. Let me leave you with a few open questions, and then I'd like to take some questions and answers from all of you. What tasks and occupations do you think will be most affected by this? What are the implications in terms of productivity and growth? What policies should we consider? And ultimately, what kind of society do we want to have? I think that technology is a tool that we can use to change the world, and we have a lot of flexibility in how we use that tool. And I'd like to hear from all of you what your thoughts are, what open questions you have, and how you would like to see the technology used. So with that, let me pause right there. Thank you all for having listened to this, and I look forward to hearing some of your questions and comments. Thank you.
And I can assure you that we have already used your book a lot in our PhD education, so thank you for that. I have a question, and that is that you described in detail that how the machines will replace human work. And that there will be a lot of excitement among us engineers that how all these things will change and what kind of new brand future we will all experience. But the question is that what are we humans going to do 2030? How do we spend that day?
So I think that would be right in the middle of the biggest transition. In some ways, it's easier to predict 100 years in the future than it is to predict 14 years in the future. 100 years in the future, I'm fairly confident the machines will be able to do almost all the things that we humans can do. And in that world, we will have a life of leisure, I hope, as long as we keep control of the machines. And that wouldn't be so bad. I think we can have a basic income. In 2030, we will be in the middle of, I think, an enormous disruption, perhaps the biggest disruption in all of human history. I think this is the biggest challenge that our generation faces, maybe that any generation faces, is to answer your question. I can tell you some of the things that we won't be doing. We won't be doing routine information processing. We won't be doing repetitive clerical work. We won't be doing repetitive physical work as well. The places we have an advantage right now are in creativity. And I showed you the robot that was playing Atari video games. They can solve very quick feedback. A good rule of thumb is if a human can make the decision within 1 second, a machine is going to learn how to do that. But decisions that take longer, that involve more creative thinking, writing a novel, coming up with a new business, developing a new economic policy, these are things that I think humans still have a big advantage and will for a long time. Science, entrepreneurship, creative arts, these are things where we will have an advantage for some time, I think still by 2030. Another big category, you may think, well, that's a little bit scary because not everybody wants to be a creative person. There's another big category where we continue to have somewhat of an advantage, and that is interpersonal skills, relating to other people. We have a lot of evolution. Our brains have billions of neurons devoted to understanding other humans and interacting with other humans. It's hard for the machines to replicate that. So if it's coaching, motivating people, if you have a football team and you have to give them a speech at halftime, you're behind by 1 goal, but you need to catch up, that's something most people wouldn't feel very inspired if a robot gave that speech, but a human who knows how to connect a little bit better, or a manager, a leader, a president, a business leader, or for that matter, a nurse in terms of caring, connecting people, a trainer or a coach, a negotiator, a salesperson who has to convince the other person, a lawyer in the courtroom, not reading the papers, but persuading the jury. These are areas where humans continue to have an advantage. And many of these interpersonal skills, by the way, they don't have to be super high IQ. They have to have a high EQ, emotional intelligence, and that opens up a lot more people who potentially can do some of these coaching and interpersonal type jobs. So those are two broad categories. I have to say that I'm not super confident, especially about the second one. I know some people in the laboratories, the Media Lab and elsewhere, who are working on technologies to, especially for the emotional connection. So the third piece of advice I would give is that we need to constantly be learning and changing. The economy is changing more rapidly than before. The days when you could go to school, university, and study when you're 18 to 22, and then spend the next 40 years in a job, those are gone. You're going to have to constantly be learning and changing. And if I give the speech again in 5 years, it may be that there's the third wave, but I don't even know what it is yet. So we have to, but we have to be ready to constantly update and change. That means being more flexible and more agile. If I was a government policymaker, my first focus would be to design policies that are not the best ones for today, but the best ones that are adaptable, that are flexible, so you can make the economy adjust. Joseph Schumpeter, the great Austrian economist, talked about creative destruction, and we have to embrace creative destruction and constantly be changing things, as individuals as well. So, it's a little bit of a long answer. I don't know for sure what the answers are. Creativity, interpersonal skills, and constant flexibility and adaptation, I think, is a good roadmap, a good place to start.
My name is Erik. When you were talking about economic implications, I think that you gave us an answer why people are voting for Brexit or why they are voting for Donald Trump. What are the political implications? Should we give a voting right to the machines?
I think that part of the anger and frustration that we have in Britain and the United States, and I think Le Pen in France and many other countries, and some of the parties in Scandinavia, is that people are being left behind. And I don't think they're diagnosing the cause correctly. They think it's the Mexican workers or the Algerians or whatever, or the Europeans. That's probably not the core problem. I think the technological change that is making many jobs obsolete is more fundamental. We need to think about the way we reskill people. We're not going to be able to just block out the Mexicans or the Chinese and think that would solve the problems. So, but I can understand and I sympathize with the anger and the frustration. It's legitimate in the sense that I showed you the chart. People are really being left behind. It's not just their imaginations. Now, in terms of giving voting rights to robots, I want to be clear that these very powerful technologies, that does not mean that they're sentient. That doesn't mean that they have a consciousness. And at least for the time being, I don't see that being on the horizon. Or if you take the 2030 horizon, I don't think that's imminent. Someday, I don't know, perhaps. But today, these machines are very powerful for solving specific instructions and carrying out things. Maybe we want to tell them what our morality is and solve problems. Today at lunch, we had a lively discussion about putting moral ethics into, say, a self-driving car. If the brakes are broken and the car has to have a collision, should it continue straight and run over the pedestrian walking in the crosswalk? Should it swerve and hit the tree and kill the occupant of the car? If those are the only two choices, we have to design what morality we want to put in the car. Ultimately, the machine will follow our instructions. And so I don't think we should have the machines voting. We have to vote on what we want the machines to do. And one of the concerns I have is not enough people are thinking about the power that we have over our machines right now.
And so now we can see that, when work is getting more complicated and we're getting smarter and we learn more, work has turned into an entertainment kind of thing. And then it means that, when we're going in that direction where, the entertainment becomes the purpose of the life, kind of what you say we are going to be doing. Then my question is, who's going to pay for the entertainment? Because we don't have work to pay for the robots. So, it looks like...
Easy question.
Is it? It sounds very interesting for me.
Yeah, well, the machines are going to do the work increasingly, and they will produce the food, the clothing, the shelter, and that will be what we get. But you're right, we are moving up through Maslow's hierarchy of needs. You guys remember that from psychology, starting with safety and food and clothing, up to appreciation from other people, and ultimately self-actualization. I think all of us as individuals and as a society, we're moving up through those hierarchies. And let me make a prediction that by the year 2030 or maybe 2040 at the latest, we will be able to solve the economic problem. as John Maynard Keynes described it, the economic problem of having enough to survive, food, clothing, and shelter. We will never have enough wealth to satisfy all of our wants. Those are almost unlimited. But in terms of our basic needs, we are on a path where we can eliminate basic poverty. If you look at the Global Millennium Development Goals, there was a project to eliminate extreme poverty. And in the year 2000, by 2015, we had to hit a certain benchmark, and I'm sorry I forget the exact percentage as I'm standing here, but I can look it up. We exceeded that. We were able to go ahead of the Global Millennium Project, which was very ambitious. And if you extrapolate that trend out to 2030 or maybe 2040, we can eliminate extreme poverty. And I think if we continue, we will be in a world where economists are not really needed in terms of managing the basic needs. There'll still be the wants and desires, and there'll be more and more psychological entertainment. We'll be spending more time with virtual reality. Facebook is investing heavily in that because they know that's the future of entertainment. And there's some philosophers who think we already are in a virtual reality world. I don't know if that's true. But I think we are moving towards a world where those higher levels will be where we focus our psychology and our attention. And work, as you suggest, will be increasingly important as a way to get meaning and contribute contributions to society and connect with our friends and to other people and to show off about how cool we are to our colleagues. And that would be where we get our motivation, not because we need to get food. So I don't know whether that's a good world or a bad world. I can see it being different things. But I sometimes call it the world of the digital Athens. If you go back to Periclean Athens with Aristotle and Socrates and Plato, they spent their time philosophizing and writing plays and poetry, and strolling around, because they didn't have to worry about food and clothing. Why? Well, they had slaves, human slaves who did that. We don't need to have human slaves. We can have robots, and they will pay for our abundance.
Thanks, Erik. I guess as a member of the Parliament, I'm getting quite excited about the prospect of robots writing the news and then robots voting. At the end of the day, that probably means that we don't need politicians at all. I had one observation and two questions. The observation is that the reason I like the work that Andy and you do, in comparison, for instance, Nick Wallstrom on artificial intelligence or Ford on robots or perhaps Schwab, is that you don't fall into the category of tech pessimists or tech optimists. You're somewhere in between. And you're very practically oriented in the work that you do. You don't only theorize, you go into the field and see what's around the corner. Now, then my question is, two of them. Number one, if you were a policymaker or legislator like myself, what would be the 3 pieces of policy advice or legislative advice you would give to a politician who's looking 15 years ahead, realizing that approximately 50% of traditional jobs will be swiped out of this country? And the second question is, when will you publish the book on the second wave?
Okay. So the first question is, I would clone more policymakers like you, not to flatter you, but people who are paying attention to these technological changes, these economic changes. My frustration has been most people in government, most policymakers, and I've met with more and more of them, I'm privileged over the past year, they're not really paying attention to what I see as the great challenge of our era. They're going to have to pay attention to it sooner or later, and it would be better if they did it sooner and started educating themselves on these fundamental forces. Everyone's going to have to know about it. The reason I got into it was I saw an exponential curve back in 1987 taking off, and I was like, oh, wait a minute, this is going to keep going upward like that. And that, of course, is exactly what's happened. And I can tell you, today, it's starting at a higher base, but it's going to continue growing exponentially. We need to start paying attention. But to give you more specific policy advice, and in the book we touch on some of this, I'll do it very quickly because it would be, you could write a book about it, we have to reinvent education. And that means changing the kinds of skills we have towards entrepreneurship, towards creativity, towards interpersonal skills. We can do that. It's a different kind of education we did before. Montessori and other schools focus on it. It has to be lifelong education. Secondly, we need to encourage entrepreneurship, like you've done a good job of it here in Finland. Not because all those people, the 50% or whatever the number is, who's going to be laid off, I don't think they're all going to become entrepreneurs. I don't think they all should become entrepreneurs. But we need to invent new jobs for those people. And who is best at inventing new jobs? It's not politicians. It's not professors. We have a category of people who invent new jobs. What do we call them? We call them entrepreneurs. They take technology, they take problems, they take worker skills, and they think how they can combine them in some new way that's never been invented before. We need more people to make that combination so we'll have new goods, new services, and ultimately new jobs. We can't and we shouldn't even try to just freeze the old jobs and preserve the taxi industry or whatever. We need to invent the new jobs, and that's entrepreneurs are supposed to do that. So we need to encourage more. It's not happening fast enough. In the United States, there's less new business formation than there was 20 years ago. Silicon Valley is a big success story, but if you take the country as a whole, we are doing a worse job of this than we used to. The third thing for policy is specifically redistribution. We have to think about how we distribute the benefits. I believe the pie is getting bigger. Some of it's measured, some of it's not measured. If the pie is getting bigger, that means we can make the poor richer, and the rich richer, and the middle class richer. All three of them can benefit because that adds up. If the pie is getting bigger, that means everyone simultaneously can get better. We, for whatever reason, have put into place a set of policies where 50, 60, 70% of the people are getting poorer, and 1%, 1/10 of 1% are getting vastly richer. We get to write we can make whatever rules we want with intellectual property, with antitrust, with tax, whatever. We can design different rules. It's a mistake to think that the current distribution is given by God or nature or Adam Smith. It's written by the rules that we have as our society. And in the first machine age, we rewrote the rules many, many times. We invented mass public education, we invented Social Security, we invented antitrust, we invented new tax policies. All these things made the economy grow faster, but they also created shared prosperity. We have to be just as creative as our grandparents were in terms of thinking what are the policies to create the kind of society we want to do. And the last thing I would say is everything I said is tentative. We need to constantly be learning and paying attention. Updating, as I try to do by visiting companies and seeing what the next wave is, what the technologies can do, and be research-oriented. In America, we have cut way back on the measurement of technological change. There used to be something called the Office of Technology Assessment. That has been wiped out of the budget. So we don't have an Office of Technology Assessment anymore. We don't have eyes and ears watching what the economy is doing. And in this new world, we have to be more flexible than ever before. We have to sense and respond. But if we don't sense, we can't respond. So we need to have a mindset of constantly learning, constantly updating, using the scientific method to adjust and update what we're doing. The next book we're working on is going to be more focused on businesses. It should come out in May of 2017. You'll hear more about it sometime early next year.
To your point, to your final point, sort of on the income distribution aspects of this. First, just a sort of observation. In relative terms, people are being sort of left behind. But if you go a bit beyond that, in absolute terms, of course, that effect is not quite so evident. And if you then adjust it for consumption, the fact that your robots produce everything so much more cheaply, of course, in terms of consumption, that difference is even smaller. But be that as it may, I accept your point. As a former economist, one would, of course, automatically say that the way we deal with this is one, through the price mechanism, and then by adjusting anything that you can't stand in terms of distribution by lump sum transfers. I.e., you would allow a labor market to work and to produce the new cheap jobs, and may I just suggest to you that a hell of a lot of them will be in supporting the people who are at the top end of the productivity distribution. I mean, if you go back 60 years in time, actually 1/3 of the labor force was in domestic service, just to give you a round number. And then, of course, getting an income distribution, which will be kind of not so nice to live with, you introduce basic income or some other lump sum transfer that doesn't involve with the pricing mechanism. Is that what you have in mind?
I think that's the conversation we need to have. We could have many choices for a future society. We could have a society where, if we kind of consider our current path, The 1%, the 100th of 1% continues to run away and maybe builds walls around their communities. I see more and more of these walled communities with private police force, private medical, private schooling, and so they're sort of seceding, and we could continue on that path. Some Latin American countries look a lot like that already. We could have a world where it's much more egalitarian and there's shared prosperity and people are more or less even. We could have something in between where there's sort of a servant class and a wealthy class that served in most of human history, as you know, was maybe more like that category. And there are many other choices that we can have. But I think that is a conversation, it was a good question to end on, because that is a conversation we need to have. We have today more powerful technologies than ever before in human history. I think there's no doubt about that. Technologies are tools. Technologies do not decide what we do. And you hear all the time from the techno-optimists, don't worry, the technologies are going to take care of us, or the techno-pessimists, we're hopeless, the technologies are going to destroy us, take all our jobs. They both make the same mistake. They think, what are the technologies going to do to us? No, completely wrong. The question is, what do we want to do with the technologies? They are tools, whether it's a hammer or a computer, they are a tool that we can use in many different ways. And so the first question we need to ask ourselves, the first question is, what are our values? What are our goals? That question is more important now than ever before in history because we have more power to shape the world, more power to change the world, as I said at the beginning, than we ever had in history. And if we don't ask ourselves what we want, I'm pretty sure we're not going to get it. But if we do ask ourselves which of the different societies we want, I believe we can achieve any one of them. And if we have this conversation in this room, and when you go out and talk to other people, you will be able to change the world. You will be able to shape the world in whichever direction you want. And we can have a discussion among ourselves advocating for one or the other of these types of worlds. I personally believe it's achievable, but I also believe it's not inevitable. It will not happen automatically. It will not happen if we just sit in our chairs and wait for it to happen. It will only happen if we go out and use the powerful tools we have today to change the world. Thank you very much.